This question says the price demand equation for a given item is price equals 50,000 minus demand divided by 200, or P equals 50,000 minus X divided by 200. Now, from that, we want to go ahead and construct a revenue function. So revenue is the number of items sold times the price per item. So that, of course, is number of items sold X times the price per item P. And you can do revenue as a function of P or revenue as a function of X. What I'm going to do here is I'm going to do it as a function of X. So here's the information that we have. Revenue is X times P. X is just X. P is 50,000 minus X over 200. So we're clear, remember X is really X over 1. So when we multiply this, 1 times 200 on the bottom is 200. On the top, X times 50,000 is 50,000X. Minus X times X is X squared. So we can rewrite our R of X is negative X squared over 200 plus 50,000X over 200 I want to get it in that AX squared plus BX plus C form, so it's getting close. R of X is negative 1 over 200 times X squared. Plus, what do we have next? We have 50,000 divided by 200. What will that give me? 50,000 divided by 200 is 250 plus 250X. Now, what do we want to do? We want to go ahead and figure out what kind of a window we want, what kind of a vertex, find the vertex of this. That's our next question. So let's go ahead and write down what we have so far. We have our revenue function. For here, R of X equals negative 1 over 200 X squared so the negative 1 over 200 will be the A part plus 250X, 250 will be the B part. So we want to find the vertex of that function. So the vertex is determined by using negative B over 2A. So let's look at that, right? X is negative B over 2A. So X is negative 250 divided by 2A divided by 2 times negative 1 over 200. So this may cause some trouble. It requires some calculator skills. So let me jump to the graphing calculator to show you how I would do it. I would probably put negative 250 on top in parentheses. When you're dealing with complicated fractions, it's usually good to put the top in parentheses and the bottom in parentheses. The bottom is 2 times negative 1 over 200. So you'll see how I've done that. Look at my syntax. The top is in parentheses here. Bottom is in parentheses here. I even put the negative 1 over 200 in parentheses. Negative button, don't forget, is this minus with the parentheses. And the result I get is 25,000. So X is 25,000. We believe that's the X value for the vertex, which is going to represent demand. But the vertex is also got to have an R value. So what is R of 25,000? That's what we're going to ask next. What is R of 25,000? That's -1 over 200 times 25,000 squared plus 250 times 25,000. So that's also going to be a job for a calculator. So plugging 25,000 into the revenue function, let's take a look at it. And I think I'll just go ahead and put the revenue function into Y1. So here we go. -1 over 200 x squared plus 250x. And we want to see what happens when we plug 25,000 into that. Let me just go to ask, fine. I've got other stuff there. I can erase it if I want, or I can just type over it. If I plug in 25,000, what does it give me? It gives me a very large number. 3,125,000. So 3 million, R of 25,000 is 3,125,000. So we have that. So that is the X value of the vertex, 25,000. This is the R value of the vertex, 3,125,000. So let's answer the questions on the paper here. What is the vertex of the previous function? Again, the X value, 25,000. And the R value, 3,125,000. We want to determine the price and level of demand that leads to maximum revenue. Well, the 25,000 was X. So the level of demand is 25,000 items. Now, how do I find the price? How do I find the price? Well, you'll recall we have this formula up here. Price is 50,000 minus X divided by 200. Well, we want 25,000. So plugging in 25,000 for X to find the price. Price is 50,000 minus 25,000 in our case here, divided by 200, which is going to give us 50,000 minus 25,000 divided by 200. Gives me 125. So the price seems to be $125. Now, what do we believe the maximum revenue is? Well, we said the vertex of the function, which would be the highest point, right, is 3,125,000. So let's just clarify that using the graphing calculator. So let's go back to that. And I believe I already have that in there. But I think my X is 25,000, so my window's got to at least go to 25,000. So maybe -5,000 on the low end, maybe 50,000 on the high end. Maybe we'll step by 10,000, put a tick mark every 10,000. But then 3 million was 125,000 was my maximum. So I don't know, -200,000 maybe, up to 5 million maybe. And then we'll scale it at 1 million. And hopefully we'll be able to see our vertex here. And sure enough, we do. I just want to find out what is that maximum value. We found the vertex using algebraic techniques. I'm checking it with the maximum finder on the calculator. So we'll go a little bit to the left of the maximum, enter. A little bit to the right of the maximum, enter. Guess on the maximum, enter. And sure enough, there's our 2,500 essentially, and our 3,125,000. So that's reinforced. So in terms of answering our questions on the paper, what are we going to do? There's a pretty picture of me there for a minute. We have our maximum revenue before was $3,125,000. But there's another way for me to get that, right? We have 25,000 items and a price per item is $125. So remember, revenue is demand times price. We believe our optimal number, our maximum will be 25,000. We believe our price is 125. If I multiply those together, what do I get? $25,000 times 125. Do we get the number we had before for our vertex? Indeed we do. 3,125,000 is our maximum revenue, and that's obtained when we have a demand of 25,000 items, and that defines a price for us of $125 per item.